This example comes out of section 8.4, log and exponential equations. Alright, so this example is quite similar to the last, except this one is growth and not decay, but we've got an E. coli population. E. coli is a bacteria that lives inside of people's intestines, animals' intestines, normally, but if you consume it without, cooking the food properly, you can actually get really, really sick. But anyway, there's a bio note for the day. It grows from 1,000 to 19,590 minutes. The question is, what's its doubling time? In the last example, we went into some depth about how to set up this equation. So if you're having trouble with this part of it, please look at that previous example. What we have here is the final amount is 19,500. The initial starting amount was 1,000. What's it doing every time period is doubling. It's been in there for 90 minutes. But we don't know what its doubling period is, how long it takes to double. So a little bit different than our previous example where we had the doubling time, we wanted t. This time we have t and we want the doubling time. So divide both sides by 1,000, you're going to get 19.5 equals 2 to the 90 over p. Again, you could have done this graphically. A lot of word problems can be solved that way because you're often rounding your answer to the nearest minute or hour or something like that. So, but here to do it algebraically, I've got log of 19.5 equals log of 2 to the 90 over p. It allows me to bring the 90 over p in front and have log of 2. I still have log of 19.5. Now, essentially this becomes kind of a cross multiply and divide situation. Multiply the p up to the left side, divide by the 19.5, and you have 90 times log of 2 divided by log of 19.5 is going to give us our period it takes to double here. So 90 times log of 2 divided by log 19.5 gives me about 21, very close to 21, 21.0015, so approximately 21, and the units here were minutes. I didn't mention in the last example because it was getting a little long with the initial explanation of the equation, but if you have an answer like this, you should take a look and see if it even makes sense. Our population started at 1,000. After 21 minutes, it should be at 2,000. After another 21 minutes, it should be at 4,000. After another 21 minutes, should be at 8,000, double it again, 16,000, and notice altogether we've gone now 84 minutes, which makes sense that because if we tried to go another 21 minutes, that would be longer than the 90 that was given in the question, and we'd have a population bigger than what we had in the question. So given that the population is somewhere here, 19,500 bacteria, it makes sense that our time period was 90 minutes. It was a little more than 84, but definitely not quite as much as 105. That method of just estimating can often get you the answer, especially in a multiple choice question where you can eliminate 2 or even 3 of the answers as being unreasonable. So do take a look and estimate in these growth and decay problems. See if your answer is even in the realm of possible.